Okay, we're doing GCSE Maths and we're looking at Trig, and now we've gone on to looking at Trig problems, which says a car drives 5 miles on a bearing of 0.75. How far east is it from its starting position? So let's see if we can get our head around what it's actually asking us here. There's our north line, 75 degrees, doesn't matter how accurate it is. So that was going to be 75 degrees, and then that distance there is 5, and we want to know how far east it is. So that's going to be that distance there, or if we wanted, it's just that distance there, which is the same thing whenever we triangle already done. So there's the distance there I'm trying to work out. This is a right angle triangle, which makes our life an awful lot easier, so we can just use SOHCAHTOA. That's 75, so that's going to be O, that's going to be H, and that's going to be A. O is the one we want, that's our east distance, and we have H, so it's O and H. So I'm going to have sine X equals O over H. Sine 75 equals O over 5. O then equals 5 times sine 75. Solving that into our calculator. I get 4.83, and that then is going to be miles. So that's that one done. V, A, B, C, D is a regular rectangular pyramid. V is vertically above O, the center of A, B, C, D. VA is 19.5 centimeters. The angle between VA and ABCD is 54 degrees, and AB is 9.4 centimeters. Calculate VO. Goodness. Alright, so we'll need a 3D version of this and then a kind of regular version of this. So it's a rectangular base pyramid. It looks a bit like this. Now let's pretend this is up here. So that's A, B, C, D, and there's V. I'm going to join all of these then to this. People find this very, very hard to picture, and this is always a bit that kind of causes the concern. V is supposed to be in the center. It's probably not. It's all right there. It's not brilliant, but we have that. And then that's O. Let's pretend that O then is in the center. What do we know? We know VA, so that's a 19.5, and the angle between VA and ABCD, so again that's very hard to picture. So if you have the flat ABCD, the angle really is there, so that's going to be then 54 degrees, and a lot of people find that very, very hard to picture. Calculate VO, so that's that distance there. Now I can see that this is a wee right angle triangle. If you picture this pyramid and you're right in the center there of that rectangle, then this is a right angle triangle that I can just lift out for that. So for part A, I'm going to lift out the right angle triangle, which is VAO, and draw it here. Now the hardest bit is picturing it, this next wee bit. If you can picture that, you've definitely done the hard bit. So that's A, and that's 54 degrees. That's V, and that's O, and we know that that's 19.5, and we want VO. It's a right angle triangle, so we're going to label our sides. That's O, that's H, and that's A. So I'm going to use, we want O and we have H, so it's going to be sine X equals O over H. Sine 54 is O over 19.5. O is 19.5 times sine 54. O, which really is our VO, that's terribly labelled, and that's okay. And so we're going cancel that 19.5 multiplied by sine 54 equals 15.78. We're in centimeters. So VO is 15.78 centimeters. So far so good. Next thing they want is AC. So that's going to be the distance from here all the way across to here. That's the diagonal of the rectangle. Now, it's actually twice AO. So that's the way I'm going to sit and work it out. I'm going to use the same triangle here and then double my answer to get AC. You could use Pythagoras because we've just worked out this and we have this other side. But I always like using the information you're given in the question, just in case I've made a wee mistake here with working out VO. So I'm going to use A and 8, so it's going to be cos x equals A over H. Cos 54 equals A over 19.5. A is 19.5 times cos 54. I don't know if you can just about see that. I'll move it up a bit. So A that we're looking for 19.5 multiplied by cos 54, and that gives us 11.46. The three significant figures, and it's going to be 11.5. Now what do we know then? We know then that AO is 11.46. We want twice that. AO equals 11.46. Therefore, AC equals 11.46 times by 2. AC, so I'm just going to multiply, keep it more accurate. And the answer I got, 22.9. The final one then they want us to work out is the length BC. Goodness, how are we going to work that out? We have our diagonal of that, we have that angle there. I will maybe come back to that one in just a second. We have no, sorry, we have AB is 9.4 and we can work that out from there. So let's see. What I'm now going to do is lift out the bottom rectangle here and put in the information then that we have. So let's look at it from a bird's eye view, and I'll draw it then down here. So my rectangle is here. So what way did I have my A, B, C, D, and what information do I know? So that was A, that was B, that was C, that was D. We have just worked out AC, which is 22.9, and it tells us that AB is 9.4, and we want BC, so it's just going to be a straight Pythagoras theorem then. So let's see, if we can either label them A, well let's just label them A, B and C. We'll keep it low, but that might kind of confuse people, but we'll keep it lowercase. I'm going to call this one A, I'm going to call this one B, I'm going to call this one C, and we're going to have A squared plus B squared equals C squared. 9.4 squared plus B squared equals 22.9 squared. B squared equals 22.9 squared, take away 9.4 squared. Squared equals, and that is 436.05, and so then B is going to be the square root of that, and it gives us 20.88.